In this video, you will learn about the movement of water through our environment. Water in forested watersheds originates from precipitation. Precipitation is a part of the hydrologic cycle, which is the movement of water through our environment. This cycle starts with precipitation falling to the watershed land surface as either rain or snow. When we add up all of the rain and melted snow, we can look at the depth of water that would cover the surface over an entire year. The depth of annual precipitation in Pennsylvania ranges from about 32 inches in many northern counties to over 48 inches in the western mountains and the Poconos. Much of this variability can be explained by the interaction of weather systems coming from the west or from the ocean, causing them to drop precipitation in higher elevations. Keep in mind that this map only shows long-term average precipitation across the state. During very dry years, only 25 inches of precipitation may fall in some areas, while wet years may see more than 70 inches. In an average year, approximately 40 inches of precipitation falls on our watersheds. About half of that water quickly evaporates back to the sky. This evapotranspiration is caused by direct evaporation from the sun, or more importantly, from the use of water by plants during their growth, called transpiration. Of the 20 inches of water that does not evaporate or transpire, about 13 inches slowly moves through soil and rock to recharge the groundwater, while about 7 inches directly runs off the land surface into streams and lakes. As the term hydrologic cycle implies, water is constantly moving through this cycle, with evapotranspiration from one watershed becoming precipitation, recharge, and runoff for another. While Pennsylvania's amounts of precipitation are remarkably constant from month to month, ranging between 3 and 4 inches, the movement of water is not constant. In fact, it changes considerably. Evapotranspiration is very low in the winter months, since plants are not growing and the sun is low in the sky. Evapotranspiration increases dramatically in the summer months. In fact, during the summer, the available supply of water from precipitation is usually not enough to meet the demands of the sun and the plants, which results in a moisture deficit throughout the growing season. In early spring and fall, precipitation exceeds evapotranspiration, creating a moisture surplus that results in the movement of water past plant roots and into our groundwater. These recharge windows are critical to ensure adequate water for our groundwater wells, springs, and streams throughout the remainder of the year. So while our annual hydrologic cycle results in about half of the incoming precipitation evaporating and the other half reaching water sources, the hydrologic cycle in any given month can be dramatically different. A further complicating factor on our simple hydrologic cycle is the role of differing types of vegetation. Watersheds dominated by coniferous forests will have higher percentages of water lost to evapotranspiration, since these trees are actively growing all year long. Watersheds with deciduous forests, on the other hand, are still dominated by evapotranspiration during the summer months, but lose little if any water to tree growth during the winter months, resulting in more water reaching groundwater and streams. In most cases, our small first-order streams start as a groundwater spring that emerges along a hillside. This emerging groundwater has a constant water temperature of about 50 degrees Fahrenheit, which provides cool water during the summer and warmer water during the winter. The moderated environment around these spring seeps provides crucial habitat for wildlife, including nesting birds, amphibians, and reptiles. Other wildlife like turkeys and deer will also rely on these spring seep areas during severe winters to find bare ground from the emerging warm water. Because groundwater springs and seeps are such important water-producing zones and habitats, they should be carefully protected from any land use disturbances.